Now I am going to discuss question number 12. This is the day before yesterday exam paper question. Combined maths paper 2, question number 12. Right? Because this question number 12 is normally, you know that always part A is from wages of pulleys, part B is circular motion. So this time also you have question in this similar pattern, right? First part, if you take, you don't need to find the acceleration, but you have to write down only the equations to determine some quantity, right? So if you let's see, this is the question number 12. Part A. There's a block is given. There are three particles. Three particles P, Q, and R placed on these spaces. Mass of P is 3m, mass of Q is 2m, and mass of R is m, and mass of the block is 4m. Right? Now you have to find now particle Q2, time taken by the particle Q to move to reach at point E. That is what you have to find. So you have to write down sufficient equations to determine this time. What is the time for the particle Q to reach at point E, right? So let's see how you can do this sum. You have to write down the equation, but not you have to notice that there are two strings in this, right? From the particle P to Q, one string. Other string is from particle Q to R. This is other string. At point capital D is a ring. Ring is there. This string passes to this string and connected to particles Q and R, right? Other string connected particles P and Q passes to a light pulley at E, right? Light pulley at E. Let's see how you can do this sum. So you can mark these weights. Weight of P is 3m. This is 3 mg. Mass of Q is 2 mg. Mass is R is mg. Mass of block is 4 mg. Right? Block is 4 mg. Weights are 3 mg, 2 mg, and mg, etc. So this string you can mark tension T. So there's a light pulley at E. Same string, therefore you can mark same tension. For the next one is different string, so you have to mark different tensions. T1, T1 like this, right? T1, T1, right? First thing, you have to conclude how you write down the equations for this, right? Do you need to write down all the equations? But here you can mark perpendicular reaction is the particle is in the other direction, right? So here also you can mark reaction S1. So this one S2. Actually, although you mark this reaction, I think you don't need this reaction. Without using these reactions, you can calculate required time S2. Right? So you can acceleration of this set of particles with respect to the block is same acceleration, right? Because this is not this inextensible string, so therefore if the acceleration of particle r is simple f relative to the block simple f, then q also has same acceleration f in this direction, right, along the inclined plane. But P also has same acceleration, simple f, along the inclined plane, like that, because all three particles have same acceleration, but relative to the block, right? Now, what is the acceleration of block? So you can mark acceleration of the block is capital F. You can assume that this block is moved this direction, this because S is bigger, because weight of TMG is bigger, because you can roughly guess that acceleration of the wedge moves in this direction, right? So acceleration is capital F. Now actually if you write down the equation, you can write equations for each of the particles. You can apply F cos Ma for each of the particle. So you can apply F cos Ma if you apply F cos Ma for the particle for P. So Tmg. So if you resolve this was sine pi by 3. Tmg sine pi by 3, because this angle is pi by 3, this angle also pi by 3, right? So you can resolve in this direction. Minus T equals Tm times acceleration, simple F minus the acceleration of this particle P attains the acceleration of block, because particle P then equals F cos pi by 3. So this is one equation. You have this equation. So 3 root 3 by 2 mg minus T equals 3m times F minus capital F by 2. So this is equation 1, right? Then you can apply F cos Ma for Q in this direction. F cos Ma for Q. That means DE direction. DE direction, then T minus T1 minus 2mg sine pi by 3. Equal. So this angle also pi by 3. So this pi by 6. So this angle is pi by 3. Right? So this is pi by 3 equals 2m times simple F minus capital F cos pi by 3. Capital F. So you have second equation, t minus t1 minus 2 root 3 root 3 by 2 mg equals 2m times f minus capital F by 2. So this is equation 2. Then you can apply F equals ma for particle r. F equals ma for particle r. So T1 equals m F minus capital F. So this is equation 2. But variables you have F and capital F, T1 and T2. In this three equations there are 4 variables. But you cannot solve 4 variables using 3 equations. So you need another equation. For another equation you can find, you can apply F equals ma. F equals ma for this direction, for the system. Now you can apply F equals ma for the system horizontally at this direction. Then what is the resultant force on the system? Right, most of all the forces are internal forces. When you consider horizontally, masses are vertical, therefore no component, horizontal component for the system. Actually, the entire system has no forces horizontally, right? So therefore total force is 0. Then capital 4m times capital F minus. Now you apply in this direction. If you apply that direction, 4m times minus F plus minus m 3m times F sin pi by 3 F cos pi by 3 F cos pi by 3 F cos pi by 3 minus F plus 2m times F cos pi by 3 minus F plus m into F minus capital F. If you simplify this one, m get cancelled, 4f plus 3f plus 2f plus f equals 3f by 2 plus 2f by 2 plus f. So this equals 10f equal here 2f 7f by 2. So 20f equals 7f. So this is equation 4. Right? Now using this equation you can calculate acceleration, simple f. Once you calculate simple left, then you can calculate uh, when the particle Q moves, Q reaches at E, then distance traveled by Q is A by 2. Then for the last one, let T be the time taken by Q2 reach at E, right? In applying then you can applying S equals ut plus half at square in this direction. So you have distance is a by 2 equals initial velocity is 0 because the entire system starts from rest plus half simple left t square. So t squared equals a over f. So this equation 5. Now using these equations you can calculate simple t by 1, 2, 3, 4, 5. T can be calculated, right? Using plus 4 equations you can calculate simple left, you don't need to find capital F. Then you substitute simple left here, then you can find time simple t, right? Right. Next let's see second part. Part B. Part B of the question is this. So this is the part B of the question. So there's a cylinder, it is fixed, its axis is O, right? The P and Q are particle connected with string. Part of the string goes round the cylinder, right? Then if you release this system from rest, it start to move. That Q is bigger particle due to weight is high, therefore Q moves downwards. P rotates on the cylinder, right? But entire system moves under gravity. There is no work done by any other external forces. Only work done is gravitational force. Therefore, you can apply energy conservation. If you apply energy conservation, then you can derive this equation, right? So you have to find when this v square velocity of particle p is v square is given by this equation. When theta, we have restricted range of the theta from 0 to pi by 6, right? Let's see how you can do this sum. Right. Now you can take this cylinder, right? When t equals t, particle is at this position. When t equals t, particle is this position. Downwards to mg. Right. This is mg. So this when t equals 0, when t equals t and theta equals theta. Suppose this particle rotates by angle theta, right? Is 2 mg. Now you can take when this rotation is angle theta. This rotation is angle theta. The velocity is a theta dot. Theta dot is angular momentum. Sorry, angular velocity. Theta dot is angular velocity. If you know the angular velocity, then you can write down the velocity of the particle. Same velocity as this particle a theta dot, right? Same velocity. When this theta equals theta, when theta equals 0 at this point, this point is theta equals 0 and t equals 0, right? Now you can apply we can apply energy conservation law for two cases. Energy at t equals 0 equals to energy at 2 equals t, right? So you can mark tension T, right? Tension T, this is also tension T, right? Applying law of energy conservation, applying law of energy conservation, then initially mass m, so this is particle p, so this is q. The particle p has no velocity. So you can take, so potential energy 0 level is this level, this potential energy 0 level. If potential energy 0 level, then potential energy of particle P is 0. Potential energy of particle is you can this distance you can take simple h. So what is this distance now? This distance is h plus a theta. H plus a theta. Why h plus a theta? Because this is this rotation is angle theta, then distance traveled by particle p is a theta. Then it's increase in the distance is a theta for particle q, right? So minus 2 mgh, right? Both particles as and what is the acceleration? Kinetic energy of particle B is 0. Kinetic energy of particle Q also 0. Then equal the potential now. When it rotates by angle theta, what is the kinetic energy of particle P? Half 2m a theta dot whole thing squared. What is the kinetic energy of particle? So here m, particle p is mass m, half m. Then kinetic energy of particle q is half 2m times a theta dot all things square. What is the potential energy of particle P? Is half this height is a sin theta, a sin theta, mg a sin theta. That potential energy increase. That potential energy of the particle Q 2mg times h plus a theta, right? So this h get cancelled both sides, minus 2mgh is there, 2mgh get cancelled both sides, so you have then thereafter m also get cancelled, then a squared theta dot square plus half a square theta dot square plus half 2a square theta dot square equals 2mg theta minus mg a sin theta. So this equals 3 by 2 a square theta dot square equals, so m get cancelled, m get cancelled, m is not there here, right? 2g theta, g a to theta. G a sin theta 2m a theta minus 2g theta. Now you can take g out. G in it, a is there, 2ag. Then you can take ag out. Then 2 theta minus sin theta. So 1a get cancelled. No, you just put a theta dot v square. You can put 3 by 2 v square equals ag 2 theta minus sin theta. So v squared equals 2ag by 3 times 2 theta minus sin theta. So theta, they have restricted theta greater than equals 0, less than equals pi by 6. Then thereafter they say that when theta equals pi by 6, the string is cut and particle P moves, particle P does not reach to the highest point of the cylinder, right? Then they ask if thereafter particle P might now subsequent motion, particle V comes to this point. It might be sometime particle might travel in a projectile and also comes to this level. This is A. When distance A below the starting point, you have to find the velocity of particle P is V. So you can take V dash. So you have to find V dash. V dash when particle. So it is very simple, because after that subsequent motion also under gravity, there is no effect of any other force, entirely under gravity. The work done is under gravity, right? Therefore, you can apply law of conservation of energy. Now, velocity is this velocity v, right? So you have to find the theta equals, when theta equals pi by 6, you can find v. What is v? 2ag by 3, v squared is equal to 2ag by 3, 2 pi by 3 minus sine pi by 6. So this equals 2ag by 3 times 2 by 3 minus this is pi by 3 minus r. So this is the velocity v squared. So v equals whole thing square root. This is the v when particle at theta equals pi by 6. Right? Velocity. Now you know that velocity. After that you can compare the velocity when theta equals pi by 2. Then energy by applying energy conservation law. By applying energy conservation law, you can find half m v squared equals half m plus v squared plus is kinetic energy. Potential energy is mg sine pi by 6. So equals, when it comes to this point, simple a depth a below initial point, right? The kinetic energy is half m v dash square minus mga. So from this equation you can find v dash. So m get cancelled. mg a sine pi by mg 2g mg a sine pi by 3, so this is equal to 2g a by v dash squared 2ga. So v dash squared equals v squared plus ga plus 2ga v squared plus 3ga. So v dash equals v 2ga by 3 into pi by 3 plus minus half plus 3GA. So you can take GA out. If you take GA out, 2 pi by 9 minus 2/6 plus 3. Minus 1/3. So this equals GA times 8 by 3. So therefore E dash equals square root of this one, GA times 2 pi by 3 8 by 3. Equals 1/3 GA 5 by 9 T5 plus 24. Right, that's all. That's a complete answer for the question.